by looking at graphing a very simple transformation of y equals sine of x, right? So we're going to graph y equals negative 4 sine of x. So we got a couple things happening here, right? The amplitude, I know, is 4. Amplitude is always absolute value because it's just the amount you're going up and down. The negative means that we're going to go down first. But the amplitude is still 4 because it's going to go 4 in both directions. Now, the period of the function, just think about this like if there was a 1 in front of the x, right? And the period of function is 2 pi over k, right? And so 2 pi over k, well, k is the frequency, and the frequency is 1, right? Because we have a 1 in front of the x. We could pretend there's a 1 here, right? So if I think about that, well, the period of the function is 2 pi. And looking over at my basic graph of sine of x over here, I can clearly see that the function does one full cycle from 0 to 2 pi. Okay, so now I'm going to go back to drawing my graph of sine of x. Well, I'm going to have the exact same period of the function, so I'm going to go ahead and put my graph from 0 to 2 pi, right? So I know that it has a complete one full revolution from there to 2 pi. Now, I'm going up farther, so I'm just going to put this to go by 2's. And here we have -2, -4. Right, so now I'm ready to draw my graph of y equals -4 sine of x. And the one thing I have to remember is because of the negative, it's going to go down first. So normally sine function, if you look over here to our original, goes up, but now it's going to go down first. So I'm going to go down, and instead of going down to -1, I'm going to go down to -4. So I put my dot here. I'm going to return to 0 here. I'm going to go up to 4, and then back down to 0. So my function is going to look like this. It's going to go back through 0, go up to 4, and now I've completed one revolution or one cycle of y equals -4 sine of x. All right, so this one's done. Now let's go on to y equals tangent of x. Now, tangent, same period as our original function. So we're just going to do pi over 2, pi, 3 pi over 2, 2 pi, and I'm going to put one more here. You'll see why in a second. We're going to have 2 pi and then 5 pi over 2. All right, now remember, important thing about tangent. Tangent is just the relationship of sine over cosine. So what does that mean? Well, it means that every time sine is 0, it's 0 over a number. So that happens at 0. You can see that the sine graph is 0, and again at pi, and again at 2 pi. Okay? Every time cosine is equal to 0, like right here and right here, well, that's a problem because we have a number over 0. Well, what happens when we have a number over 0? It creates a vertical asymptote. So we're going to have, a VA at pi over 2, a VA again at 3 pi over 2, because notice that's where cosine equals 0, right here, and it would actually happen again at 5 pi over 2. And then remember, when we're graphing this, we're just going to have curves going upward here. We're going to have this slanted motion, and now I can go ahead and graph y equals tangent of x, just repeating this curve that I see every time. And the reason why this is happening is that as sine gets closer and closer to 1, cosine gets closer and closer to 0, which causes it to go towards infinity. So do one more here, and now we're done graphing tangent.